Morning to everyone. I am Sayed Suhana, bearing roll number 5M7. Now I am going to tell from 2 CSCD. Now I am going to tell about random variables and its properties. Random variables. Random variable. Each outcome of an experiment can be associated with a number by specifying a rule of association. Such rule of association is called a random variable, or it can also be defined as a random variable is any rule that associates a number with each outcome in the sample space S, or it can also be defined in other words as random variable is any function from sample spaces to a set of real numbers. Example: suppose a coin is tossed twice or two coins tossed at a time. Now the possible outcomes are head head, head tail, tail head, tail tail. Suppose we have to speak in terms of number of heads. Now we have to assign to the possible outcomes as follows: head head can occur two times, head tail or tail head can occur one time, and tail tail can occur zero times. Again, we have to assign the probabilities to the corresponding random variables. This the probability distribution and it must satisfy two the probability distribution must satisfy two conditions. Probability are always lies greater than or equal to 0, and sum of probabilities is 1. According to the number of values, it assumes we can classify random variables into two types: discrete random variables and continuous random variables. Discrete random variables: a variable which can assume only countable number of real values, then the variable is called discrete random variable. Example: marks obtained in a test, number of accidents per month, number of telephone calls per minute. Continuous random variable: a random variable x is said to be continuous if it can take all possible values between certain limits or from or from an interval. Example: height of a person, weight of a person, age of a person. Probability mass function: let x be a discrete random variable taking countable infinite values x1, x2, and so on xn, then its probabilistic behavior at each real point is described by a function called probability mass function. If x be a discrete random variable with a distinct points x1, x2, and so on xn, then the probability mass function is defined as p of x is equal to xi is equal to p of I, such that x is equal to xi, where I takes the values from 1, 2, 3, 4, and so on. This is called a probability mass function of a random variable x, that is, it can be represented as PMF. Here p of xi must satisfy two conditions, that is, p of xi greater than or equal to 0 and sum of p of xi is equal to 1. The set of values x takes is called spectrum of the random variables. Continuous random distribution or probability density function: a random variable is continuous if its probabilities are given by areas under a curve. This is called probability density function. If the function f of x is a probability density function of a random variable x, it must satisfy the two conditions, that is, f of x greater than or equal to 0 and my integral minus infinity to infinity f of x dx is equal to 1, that is, sum of probabilities is equal to 1. In continuous probability distribution, p of a greater than x greater than b is equal to p of a greater than or equal to x greater than b is equal to p of a greater than or equal to x greater than equal to b is equal to p of a greater than x greater than or equal to b. Cumulative distribution function or distribution function: the CDF of a variable x is denoted by f of x is equal to p of x less than or equal to x is equal to x sigma f of xi if x is a discrete random variable, and integral minus infinity to x into f of x dx if x is a continuous random variable. The properties of random variables are: now let us discuss the properties of random variables. F of minus infinity is equal to 1. F of infinity is equal to 1. F of x is non-decreasing function, that is, f of x less than or equal to f of y if x less than y. F of xi minus f of xi minus 1 is equal to p of xi. Properties of CDF of a continuous random variable: f of minus infinity is equal to limit x tends to minus infinity f of x is equal to 0. F of infinity is equal to limit x tends to infinity f of x is equal to 1. F of x is a non-decreasing, that is, f of x less than or equal to f of y. If p of a less than or equal to x less than equal to b is equal to integral a to b f of x dx is equal to f of b minus f of a. F dash of x is equal to d by dx of f of x. Here f of x is a representation represents the relationship between CDF and PDF. f of x is a continuous function of x on right. On left side, f of x is a discontinuous. Expectation of x. Expectation of a random variable is denoted by e of x, is defined as e of x is equal to sigma xi into p of xi. If x is a discrete random variable, if x is a continuous random variable, then expectation is equal to integral minus infinity to infinity x f of x dx. Variance of a random variable is denoted by v of x or var of x and is defined as sigma square is equal to sigma x minus mu whole square into p of x if x is a discrete random variable, or minus infinity to infinity x minus mu whole square into f of x dx if x is a CRV, continuous random variable. For practical purpose, variance is equal to sigma square is equal to e of expectation x square minus expectation of x whole square. Properties of expectations. Let a and b are any two constant, then e of ax plus b is equal to e of x plus b. E of x plus y is equal to e of x plus e of y. E of x into y is equal to e of x into e of y. Some results are: mean is equal to integral a to b x into f of x dx, where x takes values between a and b. Harmonic mean is equal to integral a to b 1 by x into f of x dx. Let m be the median between a and b of distribution f of x, then integral a to m f of x dx is equal to integral b to m to b f of x dx is equal to 1 by 2. Mode is the value of x for which f of x has maximum. Thank you.